Section 1. Introduction to REST API Security. REST APIs are crucial for modern web applications. They serve as the backbone for enabling seamless communication between different systems and services. They allow systems to communicate and exchange data efficiently, making them indispensable in today's interconnected digital landscape. When discussing REST API security, the HTTP methods GET and POST often spark debate. These methods are fundamental to how data is requested and submitted. Many wonder which is more secure. This question is common among developers and security experts alike. The truth is, neither method is inherently safer than the other. Both have their own sets of advantages and potential risks. Security depends entirely on how you implement and use them. Proper implementation and adherence to best practices are key. Understanding the intended uses, potential vulnerabilities, and mitigation strategies for both methods is essential for building secure, RESTful APIs. This knowledge helps in preventing common security pitfalls. This essay delves into the nuances of GET and POST, exploring their security implications and providing best practices for robust API design. By the end, you'll have a comprehensive understanding of how to secure your REST APIs effectively. Section 2. Understanding GET requests and their vulnerabilities. GET requests are designed for retrieving data from a server. They are one of the most common HTTP methods used in web development. Think of it like asking a question. You send a request to the server and it responds with the information you need. You want information and the server provides it. This process is straightforward and efficient for data retrieval. A key characteristic of GET requests is that they should be idempotent. This means that making the same GET request multiple times should not change the server's state. This means making the same GET request multiple times should not change the server's state. The response should be the same each time. It's like asking the same question repeatedly. You should get the same answer every time. This ensures consistency and reliability in data retrieval. However, this simplicity comes with security considerations. Because GET requests append data to the URL, they can expose sensitive information. GET requests append data to the URL, making it visible in browser history, server logs, and network traffic. This can be a significant security risk. Sensitive information like passwords or API keys should never be sent in a GET request. Always use POST requests for such data to ensure security. Section 3. Exploring POST requests and potential security risks. POST requests are intended for actions that change data on the server. This includes creating, updating, or deleting information. Unlike GET requests, POST requests are not meant to be idempotent. Each request can result in a change to the server's data. POST requests send data in the request body, not the URL. This makes the data less visible but not invisible. While POST requests offer some inherent obscurity, they are not immune to vulnerabilities. Attackers can still intercept and view data in the request body using tools like proxy servers or by compromising the server itself. Section 4. Shared security concerns and the importance of HTTPS. Both GET and POST requests share vulnerabilities that developers must address. These vulnerabilities can lead to severe security breaches if not properly managed. Cross-site scripting or XSS attacks can occur if an application doesn't sanitize user input. This can result in unauthorized access to sensitive information. This allows attackers to inject malicious code into web pages, potentially compromising the entire system. Similarly, confused deputy attacks can exploit vulnerabilities in either method if an attacker can control a website that interacts with your API. These attacks can be particularly insidious and hard to detect. The most critical security measure for both GET and POST requests is using HTTPS. HTTPS ensures that the data transmitted is encrypted and secure. HTTPS encrypts communication between the client and server, protecting data from eavesdropping and man-in-the-middle attacks. This encryption is vital for maintaining the integrity and confidentiality of the data. Without HTTPS, any data sent over the internet, regardless of the HTTP method, is vulnerable. This vulnerability can lead to data breaches and loss of sensitive information. Section 5. Best practices for secure RESTful API design. Designing requires a layered approach. Start with a thorough threat assessment to identify potential vulnerabilities specific to your application. Implement robust authentication and authorization mechanisms to control access to your API through obscurity. Always validate and sanitize user input to prevent injection attacks. Use parameterized queries or prepared statements when interacting with databases. Encrypt sensitive data at rest and implement comprehensive logging and monitoring to detect and respond to suspicious activity.